Well, hi everybody, and welcome to SHOEphoria, the podcast where footwear myths are made and broken. I'm your host, Simon Bartold. Thanks so much for joining me. Please have a look at all of our social media platforms. You can catch us on LinkedIn, on Facebook, on Twitter, on Instagram, and of course on our YouTube channel that's got tons of free stuff looking at athletic footwear. Now, what you're going to hear in this SHOEphoria podcast is actually incredible. I know you're going to absolutely love it. Dr. Wouter Hoogkamer is the principal author of one of the most important pieces of running shoe research ever published. In 2018, his paper, A Comparison of the Energetic Cost of Running in the Marathon Racing Shoes, was published in the journal Sports Medicine, and for the first time revealed exactly what was going on with the Nike Vaporfly, the first of the so-called super shoes. And it explained why the shoe was called eventually the Nike Vaporfly 4%. But Wouter's story starts way before that. It's one of the most interesting we've aired on SHOEphoria. We spoke with Kevin Fallon a couple of weeks back. He's one of the two partners who created the brand Speedland. But his background was in engineering. Funnily enough, so is Wouter Hoogkamer's, also a background in engineering. Very, very interesting. He started off life in that particular discipline. So basically the take-home message here is that if you're good at maths, you can turn into a running shoes superstar like Wouter. Absolutely amazing. Wouter was a very accomplished scientist before he started working on the Nike project. He found his niche in biomechanics. As I said, he was good at maths and he fell into biomechanics and loved it. And especially he developed a lifetime interest in, if not passion for, energetics. Initially, this had nothing to do with running shoes, but he was simply looking at things like the energetics of uphill running. This led him into several other projects involving things like cycling, and then he made a really important step as a researcher into the field of neurophysiology, trying to unravel some of the mysteries of stroke and Parkinson's disease. Obviously very important and a direct line to footwear in terms of preventing falls in these quite vulnerable patients. Well, eventually, not surprisingly, Nike came knocking on his door and Wouter began working on a project dedicated to the development of a shoe to take an athlete under 2 hours for the marathon distance. Working with another iconic researcher by the name of Roger Cram, both scientists actually thought this achievement, if possible at all, was at least 5 to 10 years in the future. Well, history is recorded now that on October the 13th, 2019, the great Eliud Kipchoge ran the marathon distance in 1 hour, 59 minutes and 40 seconds to become the first and only man to ever cover 26 miles, 42 kilometers in under 2 hours. And he did this in a Nike prototype shoe called the Alpha Fly. That Wouter certainly was very involved in the development of this shoe. That's not a bad thing to have on your CV, I would have thought. Now, despite this, Wouter always felt like an outsider looking in relation to Nike, and much of his subsequent understanding of how the Nike shoe, this now famous Vaporfly 4%, worked has been achieved by reverse engineering with absolutely no help from Nike. Quite interesting. Now, Wouter's now moved from Colorado to Amherst, where he heads up the University of Massachusetts Integrative Locomotive Laboratory, and he's currently working on new projects with Puma. Well, we can't wait to see how that turns out. Make sure you do not miss this episode of SHOEphoria. It is absolutely fascinating. Thanks for joining me. I'm your host, Simon Bartold. Sit back, relax, and enjoy this tour de force from Wouter Hoogkamer.
You're listening to the SHOEphoria podcast by Bartold Clinical. Listen in as we delve deep into the world of evidence-based sports science, sports medicine, and athletic footwear science. Let's go and bust some myths.
Okay, well, hi everybody. This is Simon Bartold, your host on SHOEphoria, and I'm absolutely delighted to have on our show this evening a man I can't wait to have a chat to. His name is Assistant Professor Wouter Hoogkamer, and he works at the University of Massachusetts in Amherst in the Integrative Locomotion Laboratory. Wouter, welcome. Thank you so much for joining us this morning, my time, this evening, your time. How are you?
I'm good. Thanks for having me, Simon. It's a pleasure to talk shoes.
Absolutely. It's a real pleasure. I've been doing my detective work on you as usual, and I see that you did actually start out life as a civil engineer, which makes complete sense to me in terms of your now interest in athletic footwear. Would you run me through your journey a little bit of going for what I'd ask you is, what do you consider yourself now? You consider yourself an engineer or a biomechanist or?
Yeah, that's a great question. I guess there's no real straight border between a biomechanist and an engineer. So I do consider myself more of a biomechanist, I guess, because the engineering hardcore math part is in my past, and it's definitely been helpful, right? So getting all these engineering skills and the way of thinking is really helping me in my daily work. And sometimes I can just easily follow along some of these complicated analyses, and sometimes I just have to pass and let my engineering students sometimes deal with it. But at least having that background is really helpful for me to know more about the biomechanics.
Oh, for sure. It's a very handy background. I think there's a straight line between civil engineering or mechanical engineering and what you're doing now. Now, you've had a very interesting journey. Maybe you could just run us through that for a little bit. I know that you spent quite a bit of time at the University of Colorado at the locomotion laboratory there. But maybe just run us through your journey into athletic footwear.
Yeah. So basically, I was starting out playing soccer and pretty good at math and the physics stuff in high school. So I was not really thinking about any biomechanist things when I was sort of making these decisions. So I went into engineering, which is a pretty broad form of engineering, civil engineering. And right at that time, I changed from playing soccer to run and got really into track and field. I mean, it's been a long journey, but to keep it short, I got really involved or excited about studying human movement and biomechanics and running. And I could sort of integrate that passion with my technical skills and sort of worked as an engineer, went back to school, got another master's degree, and then got the opportunity to go to Colorado at that time. So I was studying in the Netherlands, in Amsterdam. Spent 6 months in Colorado with Roger Crum because I wanted to study biomechanics of running. And at that time, we didn't do any footwear, but we did biomechanics and energetics of uphill running. And that for me was like really clear, like, okay, this is what I want to do. This is what I excel at. So then went back to Europe, did a PhD more on the motor control side, more related to patient populations. And sort of had another opportunity to sort of resettle myself, like, hey, what do I excel at? What do I care about? And again, came back to biomechanics and energetics of running. So got the opportunity to go back to Colorado. At that point, we're talking early 2015 to work with Roger Crum again, and initially to study cross-country skiing of all things. But while I was there, some of these other projects came through and I got the opportunity to do some studies funded by Nike into specific footwear elements. And then had a blast doing that, working with great colleagues and under Roger's guidance. Also great runners available in Colorado to be in our studies. And then sort of becoming more and more independent of Roger and then sort of ready to move on and start my own a new position here at UMass. Again, studying biomechanics, energetics, a little bit of motor control towards walking and running. But the biggest, most recent part is all being running footwear.
Yeah, that's a fantastic journey. And for those of you that are not aware of a name that's cropping up here a bit, which is Roger Crum, who's actually a physiologist. So this is a very interesting guy, I guess, to have as a mentor, Walter, and to be working with. And yeah, he's certainly a very interesting guy in terms of what he's achieved. And you also, we're going to get to what you did with Nike in just a bit, but you've worked with a couple of interesting people because, of course, you're working there with Shalaya Kip, who has also had quite an interesting journey going from Olympic athlete, choosing the relatively straightforward and simple event of 3,000 steeplechase, as if it isn't hard enough to run 3,000 meters. You whack a few other obstacles in there just to make it even harder. But she's now forging a bit of a career in biomechanics as well. So you worked with some pretty interesting people down there.
Oh, definitely. And both these people, Roger and Soleil, are great people, both in the personality, but also in how smart they are and how dedicated they are to their work. So they're both really careful scientists. And even though Soleil is an Olympic athlete, I think her skills on the academic side are even beyond that. So I foresee a great future for her as well as a physiologist, biomechanist, scientist on the running footwear side of things.
Yeah, I've certainly been keeping an eye on her, and she seems to be quality. One of the things I noticed when I was having a look through your impressive list of publications is you seem also to have had quite an interest in cycling, maybe in the earlier years. Are you a cyclist?
I am not. I still don't have a good bike here since I moved to Massachusetts. But I mean, growing up in the Netherlands, everybody rides a bike, obviously. I think most of the stuff that I did was mainly because my position in Colorado was also partly funded by Specialized. So I got the opportunity to do a lot of applied footwear science, which in the US most often comes through industry funding. We don't have the nice setup as Scandinavian countries or Australia might have there. So, but then still I got opportunity to answer a lot of fundamental questions too. So working with Nike on the footwear side and working with Specialized on some of their bike parameters and power meters and footwear as well.
Yeah, look, I think it's interesting. I think there's probably a bit of opportunity, especially in cycling footwear. When I was in France, one of the companies that was in the same building was Mavic, and they were doing some very interesting things with carbon fabrication for cycling shoes. But they're still, I guess, relatively basic, so I wouldn't mind seeing a bit more research in athletic footwear. The other thing I'm really intrigued about with you, before we move on to some of the athletic footwear stuff, is your work with neurophysiology and neurological disease. And you've written a couple of very interesting papers looking particularly in how you might intervene with footwear in post-stroke or Parkinson's patients. Would you be able to just run us through a little bit on what you did there?
Sure, yeah. So, like I said, my PhD I did back in Belgium with neurophysiologist Jacques Duysens, who has been studying basically neurophysiology of walking for years, also focusing on people with Parkinson's and aging populations. And specifically, my project was then focused, in my case, on individuals with damage in the cerebellum through a tumor and tumor resection. What we looked at, because the cerebellum is sort of known as a part of the central nervous system that integrates input and adjusts movement, to see how that affected these individuals' gait. So we started perturbing their gait. So we had people walk on a split belt treadmill, which is basically two treadmills side by side. And then to play with that, you give each of the belts a different velocity. So with their left foot, they walk on a fast belt, and with their right foot on a slow belt. And interestingly enough, people can adapt to that pretty quickly. But if you do that for an extended period of time, let's say 10 minutes, if you then are trying to walk normally, initially you can't. You still have that sort of subconsciously stored after effect where you made a couple of changes in your gait that are still there. So we applied that there, and then again, the most useful outcome of that split belt intervention is when not to just study healthy people that come in symmetric and see if they come out asymmetric, but kind of do the opposite, where you could have an individual post-stroke that comes in with asymmetric step lengths because of paresis and have a weak side. And others have shown that if these people do repeated sessions of split belt treadmill walking, sort of 3 times a week, 4 weeks, then afterwards they walk way more symmetric, and that is a long-lasting effect that's still there 3 months later. And we were sort of interested from that perspective, see what the cerebellum does in that process, but also then now where I am now, I'm really intrigued by sort of the footwear role of that as well, and how do we perceive these belt speed differences, and can we play with that, and can we make different shoes that accentuate some of these differences? So yeah, I'm trying to integrate all of the things that I looked at before and apply it also, not just to have people run faster, but also help people with some of these neurological disorders to walk more easily.
Yeah, I think that's really, really interesting and obviously really important. And I would presume that might carry over to maybe some information on falls as well, on how you might prevent falls.
Yeah, exactly. So that's another topic that we're currently just resubmitting a grant application also to identify older individuals with a fall risk, and again, trying to either do some sort of intervention where we train them to deal better with differences in surface properties, or even use footwear in a way to modulate that. I think one of the cooler things now we're also doing is projecting stepping stones on the treadmill and give people the task to step onto those and see if we can use it as a training, but also to sort of see all the processes involved with that. And then that by itself is really intriguing, but also is exciting for some of my running students because they now are thinking about applying that sort of same protocol to see more what's going on in trail running, where it's not just a simple treadmill running at a constant velocity, but there's way more involved with adjusting step lengths and jumping over things. So using some of these projections there could also provide us more insights on that aspect.
Yeah, that's super interesting. I'd be very interested to see how that develops. Well, we can't really talk to you without going on to talk about the project you're involved with at Nike and what resulted in what is the seminal paper out of 2018 in looking at the energetics of athletic footwear. I see that your involvement with Nike went back to well before the release of the Vaporfly 4%, so back to, I think, about 2015. Is that about right? Is that when you started with that?
Yeah, I think that's about right. So when I first got to Colorado, I initially came for a couple of months to work on a ski project, but we already knew that it was very likely that we would have a Nike-funded project within the lab and that I would be working on that. So that project initially also sort of from their side originated around the idea of the 2-hour marathon, but it was basically looking into how can we translate things that we do see in the lab, whether they're footwear related or otherwise, to actually performance in a time trial. And that was the first sort of fundamental question that we addressed at that time. I think that study was sort of done over the fall of 2015 and published in 2016. So yeah, that's how it sort of started leading up to that whole series.
Did you have a lot of interaction with the guys at Beaverton, in particular Matthew Nurse? I guess what I'm interested in is at what point in time did the penny drop that there might be something quite special going to happen with this particular product?
I think that question for me that was all at a distance. So I was just working in a lab on this project, and obviously we know that it was sort of tailored towards a 2-hour marathon, but I was thinking that we're talking 10 years from now, maybe. So all of the interactions directly with Nike went all through Roger, who's on their scientific advisory board. But they sort of had this question, and we sat down also again with Shalea and Roger to address that question in the most scientific valid way that we could. And then still, I had no idea that we were actually thinking about organized attempts about running a 2-hour marathon or even about shoes that could make such a big difference. At that time, I was, again, thinking this is a long-term thing that is interesting from a fundamental perspective, but it's probably going to be on a down low for a couple more years until shoes surely get their way up there. And yeah, I didn't think about organized attempts too.
Yeah, I mean, it's really fascinating that what I'm hearing here is that it's always difficult when you're working with a commercial company because there's always that subtle sort of marketing side in the background, and you seem to have been completely removed from that. I mean, you're working with essentially a real dream team of scientists. You had some real quality in that cohort of scientists, but it's interesting that you could actually remove yourself from that and just look at the data and then present it, because I remember when it first came out, and I remember me looking at that and going, 4%, that can't possibly be right. I mean, it was a very big number, wasn't it? And to translate that for those people who are not shoe geeks, 4% it's a very, very big energetic advantage for anybody who's running, even from probably 10,000 meters upwards. It's not just over the marathon distance. So look, congratulations on that. Obviously, it's been really landmark moment, I think, for me in athletic footwear. There's been a lot of chatter about the validity of the shoe. Personally, I'm a massive fan. I love to see how the technology is evolving, and I just wonder what's coming next, really, because it's been such a big deal. I can't talk about this without asking you the question that's probably been asked you a million times, and that is, with this Vaporfly family of shoes, so we're now up to the Alphafly Next Percent, what is it that's making the difference? People are asking, is it the plate? Is it the foam? Is it the geometry, which I think is the least talked about aspect of the shoe and maybe one of the more important ones? What does Wouter Hoogkamer think is the most important?
Yeah, that's a great question. And it's interesting where I'm really on the side of reverse engineering this, right? So I was not in Beaverton when they started putting this together and what they went with. So I don't know what Nike was thinking when they were putting this together. So I'm really sort of at the outsider looking in. And I think we still don't really know, again, because we're reverse engineering the thing. I think there's a lot of interactions going on. And I think the most important thing for me is that the plate, yes, it helps, but it's not the main thing. And in a way that it helps, it's mainly related to the foam properties and the geometry, maybe even, where what we recently did too is a big literature review of all the studies looking into using carbon fiber insoles and using carbon fiber plates and see what it does. And basically what we saw when we looked at all of these different studies is that there's no clear answer to that. In a majority of cases, nothing really happens. In some cases, there is some sort of benefit. And it seems to be really that benefit is only there when the plate is not straight. So there is some curvature to it. And also that, a lot of people say like, carbon fiber plates are really good because remember the Vaporfly 4%. It's like, well, you can't just use that shoe as evidence for one of its components. That shoe, like you said, has the foam, has the curvature, and the geometry. So it's just one of the elements. So I think right now where I'm sitting at, it's mainly the foam, and the plate helps, but it has to be the right shape to help. And then obviously the geometry also plays an important part there. With increases in stack height, we do see more utilization of more foam, but also allowing for a different geometry. So again, right now we don't know what the effects of stack height are per se, because when you start making the shoes taller, yes, you get more foam, but also more lateral instability.
And changes to the moment arms, changes to the joint moment arms. Yeah.
Exactly. So again, and that's kind of why you see so many different solutions from the different brands to this. I mean, overall, for the outsider, they might all look very much the same, but I think if you just compare the ASICS shoes and the Saucony Endorphin Pro and even the recent Puma shoe, they all are slightly different, and they all sort of integrate some sort of serious toe spring with a serious stack height with a modern foam, and some foams are better than others, and they put a plate in there with some curvature, and some plates are stiffer than others and some are more curved than others. And so far, based on the results, but that could also be because they're just signing the best runners, Nike seems to have still the golden combination of those, but some other brands are getting close.
Yeah, I think the take-home message here for anybody listening is that just because a shoe has a carbon fiber plate in it does not necessarily mean you'll gain an energetic advantage from that shoe. And also important point to make is that some people do respond to these shoes and some don't. And I guess we don't really understand why that is either. Do you want to comment on that?
Yeah, no, that's a great addition to that last point too, where even if we do see a small study that suggests the one thing, it might be very specific to the people they tested. So because there is some variability in response to those things, that complicates the story even further. So again, yeah, there's also shoes that with carbon fiber plates that don't do anything if they're too flat or are in a more traditional foam that doesn't give you energy back. So yeah, all of that makes it hard for us scientists to see exactly what's going on, but it also makes it hard for the consumer to make the right decision for themselves.
Yeah, there are so many parts of the equation out there. I know I've read a bit of Emily Farina's work on placement as well. So it's not just the characteristics of the carbon fiber plate, the shape of the carbon fiber plate, but it seems as where you put it in the midsole that's also pretty important.
Exactly, and again, that's when we started throwing all these studies on carbon fiber plates on a big pile and carefully look at them rather than just adding up the numbers, but really say like, okay, what are the ones that do see differences? And we do indeed see like if a plate is too close to the foot, it doesn't have the internal resistance as when you place it further away from the foot. And then again, there's all this interaction there between what it's doing at the MTP joint, so from the midfoot to the toes, but also that geometry then and that curvature can sort of offset what it does at the ankle. And that then it gets a really complicated biomechanical story, because when the changes at the ankle, we don't even know if they're good or bad, because the forces might be higher, but then the shortening velocities are slower, and from the muscle fiber perspective, slower velocity shortening velocities are less costly. So that might be one thing. And at the same time, there's also the Achilles tendon, which could be a good thing to put some more into the tendon too, right? So we really don't know at the level of the energy using components of the muscles what all of these small changes in geometry and plate location and interactions with foam are precisely doing. And that's why it's also really hard to model it, and we can just rely on actual tests of actual people.
Yeah. It's super interesting. I mean, it's a nice segue into maybe a question I have related to some of Benno Nigg's work. And this is a question you'll probably hate as a scientist because it's going to ask you for an opinion. And I know scientists don't generally like giving opinions. But, I mean, one of the outstanding things about watching Elliot go over the finish line in 1:59.40 was he looked like he could turn around and run in the opposite direction, do it all over again. He just didn't look at all fatigued. And you talk about things like the Achilles tendon and the effect of these shoes on the Achilles tendon. Benno is very fixated on the concept of vibration, as you know, and how that might either positively or negatively affect an athlete, especially with resonance within a particular frequency range. And we got a reasonable handle on where the Achilles tendon, what its frequency range is now. Do you see a time where we might be able to do what has been the sort of lifetime goal of Benno and be able to tune a shoe in relation to vibration to prevent injury?
That's a great question. I think the important, it's great because I think originally that sort of same line of reasoning is what Benno still uses as sort of an argument against getting many benefits from the midsole for energy return. So it's definitely important to look closer at that too, where we and others have data that the midsole energy return actually does help you, but then it's really also hard to quantify like what is the resonant frequency of a midsole when it's usually a spring mass system, but what is the effective mass of the system now all of a sudden? So that makes that really tricky to pinpoint that. And then obviously that's from my area of expertise related to energetics and performance. Then if you want to take that to the next level towards injury prevention, that's another step. And I try to avoid talking about running injuries as much as I can, even though from personal experience, I know a lot about it. But from a scientific perspective, it's always tricky because there are so many confounding factors to get a clear picture of what is causing it. At the individual level, you can't figure it out because it could be just because of stress at work, for example. So, yeah, I'm not really answering your question. But I do think that it's pretty far away. Let's put it that way.
Well, I think you are answering the question. You're reinforcing what all the literature says, including quite an interesting one that's just been published with J.F. Esculier, saying that despite all the studies and all the years, we're still no further down the track to really understanding cause and effect of running-related injury. It's, as you say, the confounding issues are just too great. Well, now, Wouter, I notice you're wearing a Puma shirt now.
I noticed that too when I looked at myself, and I was like, maybe that wasn't the smartest choice, but at the same time, it doesn't really matter. So yeah, currently we have been mainly collaborating since I moved to UMass here with Puma. So they made a big move trying to get back into running, distance running. And ever since that sort of initiative got to go out of sort of their Boston office, which is 2 hours from here, it was a nice coincidence with me arriving here in Massachusetts. And we have been doing a lot of testing for them with their footwear to see basically that we're making a lot of progress for where Puma was before, but now also are actually going head to head with some of the competitors there.
Yeah, look, I think it would be fair to say that Puma has sort of fallen off the pace a bit in recent years, but when I sort of looked at the Tokyo Olympics and crunched the numbers, I would have said that Puma was maybe the sleeper in those games, that they actually performed pretty well and they got some very good results with their footwear. Okay, so spill the beans here. What are you up to? What's going on?
So I think what we mainly have been doing, like I said, is it's a big initiative from their side. So they invested a lot in hiring good people to do things better than they always did. They got new foam. So I think they have been releasing basically the shoes that we all have been testing in our lab too. I think the biggest one right now that people are probably most excited about is the Deviate Nitro Elite, which is kind of a carbon fiber plated shoe. They first came out with the Deviate, which is more sort of a trainer version with a plate, but putting in that Nitro Elite foam, which is a lot more bouncy, now all of a sudden makes it a very fast road marathon shoe. And I think obviously you can't just go by anecdotal evidence, but at least Molly Seidel was wearing that shoe when she got the bronze in a marathon. So it's not a bad shoe, let's put it that way. You can't claim on that result only that it's a good shoe. And again, we're still working. I can't obviously talk about the latest iterations of the footwear that we have been evaluating, but Puma is definitely on the right track back, and I think that nitro foam makes a big difference there.
Yeah, it's interesting that we keep on circling back to the word foam. It is so important, and for people who are not intimately involved, building a foam is basically like going into the kitchen and building a muffin. It can be a savoury muffin or it can be a fruit muffin, depending on how you want to put the recipe together, and it makes a huge difference. And no better illustration would probably be Brooks with the Hyperion, where the first one, which was an oxygen-infused foam, was not good at all, and the second one, which was a nitrogen-infused foam, was very good indeed. So just a bit of a change to the recipe can make a huge difference. So I'm very intrigued to hear that you're working on that. Well, listen, I told you I wouldn't keep you longer than half an hour, and this has probably actually been the best SHOEphoria interview we've done, Walter. I've found this super interesting, and I'm really interested in your diversity of your background. You've got a lot of skills and a lot of expertise in a lot of very interesting areas. So I just want to say thank you so much for taking the time out of your busy day. It's been fascinating. And wish you all the very best with your endeavours with Puma and also at the lab in Amherst. So thanks very much.
Well, thanks for having me. And yeah, it's always nice to talk about shoes. And hopefully you'll keep reading whatever we're working up when it comes out. And happy to check in again at that time when there's something else that we can go into depth.
That'd be fabulous, and hopefully we can catch up and I can buy you a beer at some point in time when eventually international travel is restored, which I hope is sooner rather than later, but I'm missing the footwear meetings a lot. Okay, well, I'll let you go. Enjoy your evening, and once again, Dr. Wouter Hoogkamer, thank you so much for joining us tonight on SHOEphoria.
You're welcome. Have a good day.
Thanks for joining us for the SHOEphoria podcast by Bartold Clinical. Join us next time.